Hi, everybody. Hi, everybody. Are we all engineers? Are we all engineers? If you're not an engineer, say hello. So we're all engineers. Nice. And how is it going? So today I'm going to be moderating a panel session, and I have my senior engineers with me. Permit me to sit. But the first person I'll be calling today would be Louis. Louis is a product-oriented senior software engineer at InterSwitch. He has he has led distributed teams in distributed building large-scale system. How many of you use InterSwitch today? How many people connect to InterSwitch Gateway today? Nobody here. Yes, thank you. So Lewis is one of the people that help in building that. So can we welcome Lewis on stage today? Um, I'll also be inviting Taslim. Taslim is a software developer, majorly focused in mobile development, Flutter, and he is very passionate in building clean architecture and learning how things go under the hood. So can I welcome Taslim with me on stage? Lastly would be Oluwaseyi Francis. Oluwaseyi is a software engineer and a senior Android engineer with strong background in ecosystem development and developer education. Can I welcome Shay with me on stage? Yes. So, hi everybody. So here we have our senior engineers, and we are basically going to be talking about trustworthy systems. And we understand how many times engineers want to build fast. And while building fast, we understand the importance to also build a scalable product, right? And also that scalable product should be secure. And now we have AI today, right? Many of us use AI in our development. Who doesn't use AI? Who does not use AI here? Eh? I thought someone would raise up their hand. You don't. You have not started writing code. But many of us use AI today, and we know how AI is important and evaluating everything. So today we'll be having discussion on these things. And the first question I'll be having would be for Taslim. Um, so thinking how we are engineers, right? How can engineers build a very amazing system, a scalable system, and still considering security?
Yeah, thank you. Thanks for that question. So, as engineers, when we are building, I think we shouldn't just build to build. We should factor in many other things, and one of them is security. You should think beyond the user experience, the user interface. You should think about security, and well, I know the question you asked was as an engineer, but I want to take it from another angle as a team. So I think. Observability is very, very important. When, like, you should build systems that you can observe. You cannot build a secure system if you cannot observe it, if you don't know what's happening inside. So I think that should be prioritized. Then when you can observe it, you can predict different things. You can predict different behaviors, and at the end, build a very, very secure system. So bottom line, when you're building, don't just think beyond the user experience, think beyond, oh yeah, this button works, or this link leads to this place. Think about, what edge cases, what happens if this happens, if the user goes in this direction
Yeah.
and whatnot. Yeah, so that's
Thank you
pretty
very
much
much,
it.
Taslim. I think that is very clear. I think from what Taslim is saying, it's saying that when you are building, think about the edge case, the one that you wouldn't have imagined, and also build observability in it so that you're able to check your systems like, okay, is there any loophole? Is there somewhere that can be penetrated? Lewis, would you like to add something to that?
Okay, yes. Yeah, can you hear me?
Yes.
All right. So when you're building your systems, you also, I know like a lot of times you are in a rush to go live. So you still have to follow due processes. You still have to do the testing, the integration test, the unit test, the stress test. You have to do the code reviews,
Yeah.
yeah, the merging. You have to do the static code analysis. You have to scan your codes to make sure the the code is written properly, the security side as well.
Yeah.
You're taking care of it.
I think I want to ask a question. How many engineers here intentionally write tests after writing their code or before writing their code? Don't lie, don't lie. So you write test-driven code, like you do, or do you write? Wait, let's ask like this: do you write test after the code or before the code? Okay, you do both. Okay, who does not do anyone? Just write code and you go to prod. Okay, actually, okay, if you intentionally write code because your company says it, raise up your hand. Eh? Okay, if you have never written test cases before, wow. So you guys write test cases. Shout out, shout out. So you guys are telling me you are building scalable system with correct security. All right, all right. Do you want to add something, Shay, before we go to the next question?
All right.
Yeah.
Yeah, thank you. Basically, one thing I just want to add is that the way developers actually code, uh, most of the time we don't even have like an idea, like a very full picture of what you want to build. If you want to build something, you just want to start writing the code immediately. There is no diagram, no structural diagram that actually explains what you should look at, the areas you should focus on, and how you can actually implement it in the best way. Because there's always multiple ways of solving problems, like of writing codes. But we just want to kickstart. Oh, I want to create this application. Let me just start with creating an activity, and you know, a lot of things that we need to consider. So it's best when we want to start coding. It's best we have a very good overview of what you want to do, even though you don't know how to do it. But let's have a pictorial view of how you want to achieve it, what you really want to achieve, and how you can get it done. I think with this, you can be able to see a lot of things that you are not going to you can prepare for while you are building your applications. Yeah.
Yeah. Thank you so much. That's a very real point. So basically, your system design, you can have a structured out system design, looking at, okay, does this work and how can this be better? So speaking about that, we can pinpoint some common mistakes in building system reliability. So you can mention some of the mistakes and then how to avoid them. I'll start with you, Shay. So we have some common mistakes, right, in system. So yeah, you can mention them.
Yeah.
Thank you.
So I think common mistakes that we also normally make is security, which is really important, like the most important things, right? We just want to code, but there are other people that want to use the application that they are not thinking about how to use it. They just want to use it for something else. So they are thinking the best way how they can enter your system, but you are not thinking how they will not get into your system. All you just want to do is to provide a system, provide a solution, a web or mobile application that can work, right? But there's someone at the back end that is looking at how they can get in the system, because they know that you don't have the mind keep okay, how you can make your application more secureable. So you should be able to know some files that you can actually make sure that are actually available on your code base. People do reverse engineering. How can you make your API keys, all these things, how can you make them secure? You cannot be hard coding API key. There are some things that you cannot be hard coding, some keys that that this thing should not be on your code base. Just imagine you are doing you are using Google app password API key, hard coding it on your. I've seen someone did this thing recently, one of the people that I was mentoring. It's even a public repo. You hard code API your API key and you push it. So when he was telling me, I was just having a lot of concern because they don't know. So what I'm just trying to say is that security is most important thing that we can always look out for in everything we are doing. And now we also make sure that there are some things that are actually encrypted that does not have to be available for other people. It could be between your backend and your mobile or web application. Just make sure that there are some things that needs to be secured, are well secured in a way that an average person cannot just get to your code and understand what is going on there. So apart from that, one of the things that I also want to mention is having the mind of customer, because this customer too, they really want to have a very good experience when they are using your solution, right? When they are using the solution that you've built. So you as a user, don't just write code. The fact that it's working then. let's QA, go and test. Have you tested yourself? Because a lot of developers actually do that because they feel like QA will test. Let me just write the code and push it to QA. Test it yourself. Let it work. Even before QA push, you can even still test again. Make sure that whatever you've done, you are proud of whatever code that you've written and you are very sure of it. So, like I said, security and most importantly, having in mind of a customer that are going to be using the application so they can have a very good, sweet experience when they are using the application. So when they see the application, they can be like, wow, I like the developer that built this thing. And they can even go and look for you on LinkedIn. Yeah, thank you.
Thank you so much. You guys, you know what I remembered? Fun fact. When I was still learning how to code, don't judge me, please. I added my OpenAI secret key, Abi key, and I pushed it to my GitHub repo. But as I became smarter, I went to remove it. But don't judge me, don't judge me. So Lewis will be adding to that. So Lewis, what do you like to say?
Okay, like you said, you have to develop with the idea of security in your head. So when you are building, you're not just building for the success scenario, you're building for the failure scenario as well. So as you're building, you're trying to break your own system. I think there's something called chaos engineering where you have like a service or a system in place that attacks your system. So it tries to bring it down or randomly just like brings the service down and sees how your system behaves. Does it bring the entire system down? Is there a failover or just pushes like a lot of traffic to one service and sees whether it like use like load balancer to like balances the traffic. So when you're
Thank
building,
you.
you have to build with this in mind.
All right. Thank you so much. I think that's also very important. Building for failures, not only success. Anytime when we see that our code is working, we just assume that it's working, and then we say everything is working, but we forget the failure part, and we don't look at that. Many times you can even load test. What if 100 people just use this endpoint at once? What will happen? Thank you so much. Do you like to add something, Taslim?
Yeah, I think they've said most of it. I just want to double down on exposing sensitive data within your code base. It's more common than you think, and it goes beyond API keys. There are many other things that you should not expose within your code base. Apps are relatively easy to reverse engineer. I mean, there are standard ways to prevent it, but yeah, people break apps all the time. And when they see these are vulnerabilities, and when they see them, it's so easy. So yeah, it helps to be very, very mindful of these things. Be very conscious about exposing sensitive keys. It could even be maybe a URL that's not meant to. It could be anything. Just stick to standard practice on properly.
Yeah, thank you so much. And I really like his contribution. That's why I gave my OpenAI issue before. Don't judge me, please. Um, but looking at how AI has come to stay, right? AI is here to stay. Let's not lie. How do you think it strengthens and weakens security and resilience in our system? Do you understand the question?
Okay.
You know that AI has come to stay now. So, like, how does it actually strengthen and how does it actually weaken reliability? Because we know that AI has its own hallucination.
So the thing with AI is basically it does things faster than you. So you can give it like a large data set and it helps you process it in like seconds. So that is the strength of AI. It's faster, it's more efficient. It basically could see an issue or a problem very quickly.
Yeah.
And if you can see it quickly, you can solve it very quickly. But also you said
The
what's that now?
weaken, it
Yeah, the
weakens it.
weakness of AI is I think a lot of people have started relying on AI too much. So yeah, so like if yeah, we know sometimes it could be wrong. ChatGPT has been wrong a lot of times. So because you rely on it so much, you don't question it. You don't like go over and review what it gives you. So you basically just yeah, this is it. This is the question. This is the solution. You
And you
just
just
push it.
copy.
Yeah.
Yeah. Before I go to Taslim, I just wanted to ask this question. How many of you have ever used AI to an extent that you said, "Oh, I beg, I don't need AI again. I can use my brain." How many of you? Has it happened to any of you? Like, you're like, I beg, AI. I've been using my brain before you came. Please. That is how frustrating sometimes it can be. But we are talking about resilience. What do you think, Taslim?
Yeah,
Taslim.
so I will paint a very practical scenario. I work at Carrywise, and at the start of this recent AI wave, we had a lot of skepticism at Carrywise. Do we use AI. Then the agreement we had, I mean, we have a very conservative CTO, I mean, in a good way. But yeah, so the agreement was, nope, we are not feeding our code base into any form of AI. But I mean, over time, it was very, very clear that AI had come to stay, and we saw how other companies, other individuals were actually using AI for to enhance productivity. So yeah, eventually we hopped on that train, but we had to have an internal session on a responsible way to use AI. Fine, AI boosts productivity; it helps you achieve stuff faster, build stuff faster, but you also need to know, I mean, stepping away from the security part a little bit, AI hallucinates, and I think we need to know that it's not perfect. It's very good, but it's
Yeah.
not, perfect. We need to know, yeah, we need to know these things. Then also from a security standpoint, I mean, it depends on what agent you're using or what, there are actually a lot of not so trustworthy ones out there that are actually capable of taking your data, taking your information. So I mean, of course, there are the popular standard ones that have those long T and C's that nobody reads, but they assure you that yeah, we're not going to use your so you also have to be mindful of these things and be mindful of what you actually feed into the and the kind of agent you are using. Yeah, so yeah, that's
Yeah,
it.
thank you so much. So, from what Jaslim is saying like you have to be careful with your use of AI. And I can give you a very simple scenario. Let's say your company is using ABC. You don't have to go and tell code ABC. Please tell him XYZ or something different. Basically, so it doesn't like understand that code. Because honestly, they are training the AI with your code. If you think they are not training AI with your code. And I would like to ask, so there are like different, there's Cursor. How many people use Cursor? How many people use Copilot? How many people use Claude? So which is the best? Eh? Claude. I think it's Cursor. I'm biased. What do you think?
I have no idea.
You have no idea. All right. Oh yeah, wait. Oh yeah. If you are for Cursor, clap once. If you are for Claude, clap twice. Ah. If you are for Copilot, clap half. All right. Would you like to add something to that, Shay?
Oh yes. I think I'm going to continue from where you stop, and in terms of not giving AI everything, right? Just imagine like you have like something that you guys want to work on in your organization, and you think that this thing is actually something that's maybe really secret and all, but you went to go and put all the idea, just give AI back you know. Just imagine when you give AI, you feel like AI will not do anything with it. Don't forget, we are training this AI with our data,
Hmm.
and is how we feed this AI with data. That is when they learn more. If you don't feed AI with data, there's no way you can get this thing. AI does not have the opportunity. They don't have the mind to start thinking. They don't have their mind, like the mind to think on their own right now because we don't give them that kind of opportunity to. But I hope one day we will not do that because it's going
Yeah.
to be crazy when AI can now start, thinking for themselves and start making decisions on them for themselves. So right now we give them data, so we should be very, very careful of the kind of data that you're giving AI. Even though you want to give AI your copy or all your secret keys, everything, AI me, all those things that are not really safe. Like I won't say like it's you should just be careful of the things that you put there. So another thing I want to say is that AI is actually making work more easier now. There's a lot of things that we struggle to do, and but now it makes things more easier. You want to write quick scripts on time. It
Yeah.
makes things more effective. But another thing is that are we trusting this AI? Because sometimes it doesn't give us what we want. Yeah, sometimes it doesn't give us what you just be like, oh, this code is not working. Generate another one. It's not still doing whatever you want. So we should be able to like make sure that we understand what we really want, how we can rewrite our prompts correctly, and how we can make sure that we get what we want from this AI.
Yeah.
So and the fact that we don't also have to depend on AI too much because a lot of people are actually missing fundamentals of all these things that we do because you just feel like AI can always get it. You don't want to like check back, go back to the fundamentals. So I will always say that no matter how we use AI, please let's make sure that the fundamentals of coding is really important in everything we do, and it will always help us in how we are actually working and being productive, basically. Yeah.
Thank you so much. Thanks so much, Shay, for what you said. But I can say from my own point, from everything they said, I think what you summarize is that AI is very good to help you build fast. And if you use AI wisely, you will get the best results from it. So, for example, you want to build an endpoint to fly a jet. You can just tell it, how can I fly a jet? And explain it in details. And you can read the things it says. When you read it, what it says, you can now like, okay, break it down as a human being, as an engineer that is solving that problem, and not as AI. Don't just copy and paste the code. Many times, even if AI writes the code, read it to understand, okay, how did you, how did you can even ask AI, how did you explain this code you just wrote? Do you understand? So that's like wiser ways to use AI. So that will bring me to my next question. So the work of an engineer is to solve problems, right? But looking, how do we now build a very good and resilient system from innovation, like, okay, there's this problem, I want to solve it, right? To building a secure and scalable system and that is not secure. Do you understand? So I found the problem, right? I want to start building. I have my solution. How do I now make sure that it is secure, it is scalable? Do you understand that? Yes. So that's one question. I think, does everybody have that question in their mind? So I want to build this system. I have this problem. I want to build fast. And I also want to build something that is scalable and is solving the problem for everyone. So what's one thing that you're going to tell me, or what's one thing that I should look out for every time? Tasneem, you're very eager to answer.
Yeah, very interesting question. So, as you are ideating, as you are coming up to your idea, oh yeah, I want to start. From that point, you should also start thinking about, awesome ways to secure a system. I said something, the first time I spoke about observability. Have that mindset of building an observable system, a system where you can see inside and you can predict. And yeah, so I think that's the first thing. Bear that in mind as you are
Sorry.
building, you.
When you talk about observability, can you give examples?
Okay, so there are many actionable ways to, do the observability thing. You can do it in form of analytics, like, there are many analytics tools out there. Yeah, so basically, track user behavior, user action, and whatnot. Then, depending on the analytics tool you're using, you can monitor the dashboard. Okay, most users are dropping off here. Okay, most users are not, proceeding from here. Oh, yeah, some users are doing this in a weird way, maybe the wrong sequence. So basically, you can monitor your system. That's
Okay.
kind of what I mean by.
Sorry, can you give us like example of tools that can help us with that?
Yeah, there is Singular, there's Adjust, and they do more than just observe. They also track, they also, many of them, with this new wave of AI, they can also advise based on metrics that they've recorded. Yeah.
Has anybody used any of those before?
Adjust, Singular, there are so many. Yeah,
Grafana,
the options are many.
Prometheus,
Yeah,
Datadog.
yeah. So I think building a system that you can observe, then obviously while building, it should also be a security in mind. Like they said, do not expose your API keys. Then even beyond that, do not expose any API secrets, any sensitive data. Then write tests. It helps. It helps. It also helps you understand what you are building and also predict it. Predict, edge case scenarios and all of that. Yeah. So yeah.
Thank you so much. Louis, do you have something to add?
Okay, yeah, it's very similar to what he said. So at the beginning of your coding, that's the planning stage. You could start taking up the security from there. You could plan the access controls and privileges and permissions the system will need. Then moving forward on the coding stage, you could have like ESLints or a software or tool that could help you with the coding. So as you're writing your code, it's telling you, oh, this thing, why are you putting the key here? Why is it a string? It should be like a properties or something. Then the testing, you're doing all the test dimension, integration, penetration, stress, and deployment. So before you deploy, you do your SonarQube, Fortify, static analysis. Yeah, basically just at every stage of development, you are security conscious.
All right, thank you very much. So from what they said, they mentioned that at every stage of your coding, just be very security conscious because the hackers are ready for you. You will not just know. Shay, do you want to add something before I ask?
Yeah, I think one thing that I would like to add is that we should always start our coding with a mindset of scalability. Most of the time, they will just come with is a small application, just put this thing, it's fine.
MVP.
In a few months, they will start telling you to start adding different things. By that time, you've actually missed out some components that you should have maybe you should have added from the beginning of your code base. You just feel like, it looks like I will have to rewrite this code or I will have to like do this thing. By that time, I feel like, let me just quickly add this one. Trust me, you are not building for scalability. You will come back to rewrite that code. Because at that time, because you've already messed up already from the beginning, you just know that. Let me just even tell the management that we want to rewrite this code sometimes.
Yeah.
So all I just want to say is that let's always have the mindset of scalability from whatever application we are being, no matter how small the MVP is. Have the mindset that there will always be an addition to this application. So whatever architecture you want to use from the beginning,
Yeah.
that can be scalable. Make sure that you're able to figure it out. And oh yeah, thank you.
Yeah. Thank you so much. I think I've heard of a company that they dropped. hmm, Should I catch them? Okay, I'm not mentioning the name. This company, they've never gone to staging because there's always a problem in their system design, and so they had to always restart and restart and restart. So don't be like them. They're a company. Just take it like that. So before I go to the next question, does anybody have a question in the crowd? Any question? Okay, somebody. I'm coming. Sorry. Yes, cousin. You can stand up and ask. Sorry. All right. Who wants to pick first?
Yeah. So
You're ready.
I want to talk about most of this code that we inherit. I think most of us like have experienced, getting a code where you did not write, and you see this code, you're like, oh my god, like you cannot even cry. Like maybe it even took you some weeks before you even understand what's going on. You have to start calling the person, and the person is not even responding. You don't know what is going on in the code base. We've experienced a lot of things like that, and most of the time, trust me, it's not always advisable to keep building on things like that. The best thing is to just probably maybe start a project on your own end, on the side that you can maybe see how you can start something and start building on the side while you're actually maintaining that one, because it's a disaster when you keep maintaining like a legacy code that it's not scalable, because things are improving. All these technologies that we are using are actually improving.
Yeah.
But you just know that okay, one library that you're using does not support it again. You just feel like how am I going to solve this problem? And you just like and you will just change one library and everything will just scatter. So the best way is just like start out like work on a side project, start thinking about how you can work on this thing yourself to make it better for any other person that will come back and and start working on it, such that when another person start working on this project, when another person come on board on this project, they'll be happy to use that code. Of course, I've seen projects that when I saw the code base, I was sweet. Things like that makes developers happy. So be able to be proud of yourself, such that developer can see your name, like on it, that this code is written by this person,
You
can
can
be proud
search
of you basically. So maybe I will just
stuff like
pause
that.
on that so my colleagues can answer the.
Okay. Yeah.
You have
So
two questions, so maybe you can start and then answer the second question.
for your first question, these things happen, but I mean, the case of you wrote tests and something, an edge case still popped up that deviated from the test you wrote. Yeah, so these things happen, but there's one way to reduce the probability of that occurring, and that's to improve your test coverage. And it's still not 100% guarantee. I mean, I don't know how many people are active on Reddit. I've seen many debates about test-driven development, but that's a different topic. Yeah. So I think one way to solve that is to add more edge cases, improve your test coverage, and that would, like, I mean, further reduce the probability of unpredictable behavior. Yeah. Then, okay, you want to take the second question?
All right. I think they both talked about the two questions, but I just want to add my input in both. So the first one, I would say, if you inherit a legacy code, that's why we always push for microservices. So if you have like different services for each functionality or each service. So for example, let's talk about Netflix. Like you have like a service for accommodation, you have a service for login, you have a service for like list of movies. I don't know. So if you inherit a code, try breaking the code small, small. So for example, if you want to do a new implementation or you're working on an old implementation, you could like do it in a different service, use like a proper new technologies there. So by that, gradually, small, small, you would you complete or cover the whole project after a while. And for your second question, like he said, there's no system that's 100% secure. So that is that. But also you need to like plan for the worst. So you need to make sure that you are ready to fail safely, and so you can fail and the entire system is disrupted. Like everything just goes down. But you have to plan to fail safely, and also to basically get back gracefully. So you know, like your service comes back up very quickly. So yeah.
Yeah. So from everything they said there will always be legacy systems, but just make sure that you improve it than adding more to it, because one day is going to break. And then for the test-driven system, there's no basic 100% secure system, but you can make your system 99.89% secure by preventing loopholes, right? So, yeah, you have a question? You can, for other people's sake, give us two.
So, okay, thank you very much. Right. My first question is actually about the test coverage because I've noticed as an engineer, your test cases will always pass. There's never a time that your test cases will not pass because if your test cases don't pass, you comment them or you remove them from your code, honestly. So that means that your tests are limited to your understanding of the problem statement. How do you ensure that you have, first of all, you have enough context around the problem statement? And there are times when you are testing something that, let's say you made an update on a function that happens over here, and there is another function somewhere over there that is using that same function. But then you didn't know, you didn't have context about that. But your test cases will pass for this. And for some reason, the engineers that are writing code for that function didn't have a test case, an integration test for, both of them together. So how do you ensure that even when your test cases are passing, you are still able to handle those kind of scenarios? So that's my first question. My second question is about, I think, Teslim, you were speaking about observability and analytics, right? So my second question is, like, how much logs, like, are too much? Because there are times when I want to add more logs to a function, but I'm like, okay, I don't want to make this function look messy with too many logs. And at the end of the day, when we go to production, my info logs are not going to be there. My debug logs are not going to be there. Probably only my error logs are going to be there. How do you ensure that even with the limited amount of information that are in your logs, you still have proper context of what is happening, what is failing, and you have an idea of how to solve it? Thank you.
All right, thank you very much. Lewis, which of the questions would you answer?
Okay, let me speak to the logs. So I know for me myself, I write a lot of logs too. Like sometimes when I'm having some issues with my code, you see me, I'll put log in the first line. log the third line, log the fifth line, and then push it just to see like what is going on with the code. But at the end of the day, when you are going live, you basically remove most of these logs, yeah, and then you leave like the most important ones that basically help you debug if anything goes wrong. And also, another thing you can do, since you said how much log is too much, I don't think there's like too much logs. What I do personally is my logs, I keep them in like files, and after a while, I start archiving those logs. So if the files get too much, I archive it. Like probably like move it to like a different server or something, but it's still accessible if you want it. So maybe we could try that. Yeah.
All right, thank you. Do you want to answer on this?
Yeah, the first question. Yeah, so first thing I want to say is about tests always passing. Yeah, I mean, before you merge your PR into, I mean, most of the time you need to make sure that all the tests are passing. But however, when you add a new feature, when you edit, I mean, when you edit a feature, yeah, you might see cases where old tests start failing, especially when there's a new behavior and you have to update the test. Yeah, so the thing about commenting them out, people do it, but I don't think it's a behavior we should encourage. Like, I mean, deleting tests or maybe commenting them out when they are failing. It's not standard behavior. It's not good behavior. Yeah. So I'm trying to remember the full scope of your question so the answer is fully. But what I remember is you painted a scenario where you have one function that is tested, then you have another part of your code base, I assume, and that function that is referencing the old function, and you don't really have, you don't know how that function works, or you don't know exactly how that function works. Yeah. So this happens. Ideally, I think the scenario you're painting might be, I assume, maybe the existing test cases were not actually sufficient because ideally, like, I mean, you should have, tests for everything. So I think, I don't know if they would have a better idea, but what I think is you just need to find a way to understand that part because you still need to cover it. And if a function is only supposed to do one thing, like, I mean, standard
Yeah.
programming. So if a function is already doing more than it's supposed to, if you're adding, you can basically split it into multiple functions, and I think it would be easier to test and obviously write new tests or modify the existing tests, and I think that would simplify the problem. So I don't know if there is a better
Should you have something to add?
solution or alternative.
Yeah, I think probably that's what I would have said myself because I'm not sure it's a good it's a best practice to maybe comment such code out. I think the best thing is to try and understand what's the difference between this same code that is doing the same thing and this. And if it's a function, I don't see any reason why you cannot even put it into AI. This code, check it, what is going on? This one is working, this one is not working. Yes, it's a function. So I think it's not something that you should comment on. Let's try and
Yeah,
figure out how to fix
the
that
issue.
issue. And for the second one, which is logs, I'm not sure there's any log that is too much. As far as the log is actually giving context of whatever your application is doing in the field, whatever your application is doing in production, as far as giving you everything you want, I'm not sure there is any log that is too much.
Thank you so much. I'd just like to add, sorry, wait. Don't don't log sensitive things to don't go and log passwords and encrypted data. And the first one for test, don't remove anybody's test or comment out anybody's test. Write the test to pass and make sure the test pass before you push. So you wanted to please a quick follow up because other people have questions.
Yeah,
Yeah.
sorry. The reason why I mentioned the logs thing is at some point our logs were getting too expensive, right? Um, so I understand that obviously you can manage it by probably like you said putting into a file, archiving the file, but at some point that also becomes expensive. You don't have infinite storage, and your logs are not free, right? So how do you ensure that you have like the best the best logs for your current budget? How do you manage your login budget?
Have you tried Google Cloud Logs? It's free.
Google Cloud logs are free.
Yeah. I've been using it for free. Maybe I don't know. Maybe I should not say this, but yeah. But you can try Google Cloud
You can
Logs. Yeah.
try it. But I think from my point of view, I think you should just log what is actually important. Um, I'm an engineer now.
So I think most places should log at the failure points. So when you're getting
When
from
you
the
expect,
DV or you're getting input from the user, that's like the
expect.
points you should log.
Yeah. So when you expect that, okay, there should be a problem here, or there should be just log those ones, so you don't bombard it and you have to save costs. Thank you. Any other question? Hi. Oh, sorry. Actually, so it's Anne first, but let's come to her then you. So you can. I'll pick the questions together and then you make it brief.
All right, thank you. Good morning.
Good morning.
Since we're talking about secure, scalable, and reliable systems, the question that I have is, what are some defining marks of architecture that is built by, or systems that is built by, I want to say, a more seasoned engineer? So in the beginning, when you're learning to build systems, there are certain things that you learn from I don't know, school work, senior engineers, but like, what is that? What are those things that kind of take you above the court? So recently, I've been learning about things like observability, um, certain things. I'm trying to figure out, like, when we talk about secure, scalable systems, there are systems and they are like systems. What differentiates scalability at like Netflix from scalability at a decent a decent sized company? I mean, we know about microservices, things like that, but like, what are those things that make you an engineer in terms of building from the ground up? And a lot of the times, I think you don't have the luxury of building from the ground up when you join a company like Google or Netflix, Cowrywise, Paystack. So what are those things that when you see this code, you realize this is made by someone who thought ahead, someone who's thinking in the bigger? Thank you.
Thank you so much. Sorry. Before you, let's get the second question so we can wrap it up. We have. Hi, your question.
Yeah. Um, Thank you for the session. So I wanted to ask, like how do you write code with AI? So I remember when ChatGPT just came out. There was this crazy hype all over. It's like he said, it's the most used software product that we downloaded ever. After like when it was launched, that was the most used software app that exists. So I want to ask, like how do we use AI to write code, and what model, what AI model? Like I don't know if you have any like tip or.
Okay, recommendations. All right. Thank you so much. So I think we're going to pick it one. So somebody's going to answer us on system design and how do you use and scalable system. So who would like to answer that first?
Okay. So what I wanted to say is that I'm not sure there is a single part
Pattern.
to it. There's no single part to it. I think what you want to do will determine what your system architecture will look like. And when you can say, when you see a code and you feel like, no, this person that wrote this code for this particular thing actually think very well before they are able to come up with it.
You know,
I
that's how
think
you
one of the
expect
things
to
that
work on.
people like that
Let
do
me
is
share
because
parts for that.
of architecture. They make sure that they solve the problem on the board before they write the code. And that's one thing I myself did not learn on time. Like when I get to know about this, that's when I realize how important system architecture is. Sometimes, go to interviews, they'll be asking you to do, you just be like, why all these things? But it was later I realized why it's really important, because you will have like an overview of what you really want to do. Trust me, that's when I even realized that there's no problem that cannot be solved. But when you want to start with code, that's when you start seeing challenges. But when you take your time and you understand the requirements, how you can bring them together and solve the problem, trust me, writing the code will not even be a problem. So your system will always determine the architecture, and you can always have team members that can always contribute to whatever thing that you are doing, because everybody has different ideas and everybody is brilliant. They can always bring inputs based on their expertise and all, from security backend,
Thank you
and
so
all. Yeah,
much.
thank you.
Thank you so much, Shay. Lewis, please, could you quickly
Alright.
answer the AI question?
Okay, so for the AI, I don't like recommending AIs because myself, I'm very wary of all of them. So I'm not sure. Maybe you could.
Yeah. About the AI question, how do you write code with AI? So I think most people that write code with AI use plugins on their existing IDEs. If you use, PyCharm, VS Code, Android Studio, whatever it is, yeah, these IDEs support plugins, and you can easily integrate whatever plugin you want to use. There was this, I mean, there are many. I'm trying to remember the name of one of the most recent ones. Fire something. It's not Firebase Studio. It's Fire. It's Android related. I mean, anyway. So yeah. So yeah, plugins. Then also there are some IDs that we are seeing some new IDs that are popping up that have the whole AI playing field ongoing. Then depends on what you are using, whether it's Lovable, Cursor, Chat, GPT, whatever it is. Yeah, but most of them AI plugins, IDE plugins rather.
Thank you so much. Thank you, everybody. I hope you had a very enjoyed this session and you've learned a lot. If you have other questions, you can see them before they run away because your senior engineer will run away. That's just a side gist. So before we go, we are supposed to take a group photo together. Where is it?